Всем привет, everyone. And thank you. So, talking about modules, the stuff that kind of makes everybody uncomfortable and uh, secretly cringe. It's like, oh, you're doing this, you're doing that. And one of my motivations for writing about this stuff and about speaking about this stuff was that there's a lot of discussions about modules and module systems on the internet, but most of the arguments presented are not very relevant. They're not very relevant in the sense that they might be correct, and they might be correct pertaining to the hypothetical models that we have about the standards and everything. But like, what is like the actual source of truth? Is the standard something that is like 100% in effect? Mostly not. And the actual source of truth is the code, because the code is usually a completely different story. So we'll hopefully dive a bit through actual Node.js core code today and see how modules are implemented, how they work, and what are the challenges. So let's jump into it. So about myself, of course, because you have to make everything about yourself. I work on Node.js and Electron, and I contribute to V8 and different TC39 projects these days. I've been a Google Summer of Code student, and I have to write that last one. I am a speaker. Relax. I got this. So yeah, let's start with the basics. So what is a module? A module modules are the fundamental building blocks of the code structure. It's one of the oldest ideas, I'd argue, in computer programming. People have been trying to create modularity since ever. And it's something that we'll struggle with a lot in different programming languages and in different things. But it's really interesting with JavaScript, and that's what we'll find out. But like, we are where we are, but how did we get there? So let's start with history, because ours is pretty, like, definitely not dull. It's pretty messy, and we had a lot of iterations. So let's get through the history first. So March 1996, JavaScript 1.0 was released. In a famous 10-day period in 1995, Brendan Eich created a version of JavaScript for Netscape. They didn't call it JavaScript back then, but they created Mocha. And people started to use inline scripts in their HTML files because, yay, JavaScript. And once that happens, the era of the script tag begins. So until this point, JavaScript is not very big. JavaScript is like a toy language. It's basically mostly only used for form validation stuff. But form validation is not easy either. And it keeps on getting more and more complicated. Like most of you people might be actual, write production front-end code. So you know form validation is no easy thing. And files kept on getting larger. The code kept on getting more complicated. And people were like, my JavaScript code is too long. So what we do? Let's break your code into multiple files. Easy approach. We've done this before with header files in C. It works out. So this has some benefits. The benefits are we have basic modularity, but this basic modularity comes with a couple of drawbacks. Now, the first drawback is there's no dependency resolution, so it's all out there. And there's a lot of namespace pollution, because we're sharing globals between scripts, and not the best idea. Around the time of 2000, like, people did this for around 10 years, but then like prototype.js came around in February 2005. August 2006, jQuery was launched by John Riesig. Underscore came around 2009, and 2012 you have Lodash. The question is, what do all these libraries have in common? They're spaced around a long interval. But the problem is that they used a slightly different, slightly more advanced approach to dealing with modules, which is, see, do you have 999 plus global variables in your code? If you do, use ifs, because they're good. And now you get one global variable. Now you get the jQuery $, or the underscores underscore. And that's convenient. So this has a couple of benefits now. we all still have basic modularity, and we have less namespace pollution, so yay for that. But the drawbacks are there's still no dependency resolution. So like we all remember the problem that you'd have is like jQuery file needs to go on the top, and a junior developer will be like, why does it need to be on top? It's like, it has to be in the top. Include it in the head if you want, but like otherwise you'll have the symbol not defined, and that's a messy thing. And you also still have namespace pollution. Like there's only one global variable, but there's still global variables. That's not something that's 100% optimal. And also it's a messy syntax. Like nobody, I think, found the ifs particularly eloquent. It was just like something that we had to do. So we have invented Fire. We have a basic system that enables people to do basic things, but we got to go forward. So 2009, a crazy dude, he happens to sit between us today, decided, OK, we can write JavaScript on the server. We should try it sometime. And people decided to write a module system for that would work out with something like this. I mean, how would you compete with Python and Ruby? You need a module system. And it initially started off as Server.js, and Server.js later changed its name to CommonJS. Now, CommonJS is not a JavaScript library or anything. It's just a standard that defined how modules would work in the server-side JavaScript world. But there was a couple of benefits to it, obviously. Now we have proper modularity. The existing state-of-the-art modularity at that time, which was close to what other languages offered, it is 100% independent of HTML. So you don't, because like Node.js, you have no HTML file to like have script tags, and how do I include stuff? This is how. But it has drawbacks still. The drawbacks are everything is required synchronously. So it's not very practical on the front-end side of things. You can't just like stop everything and fetch a module on the network. It takes too long. So a couple of facts. Node.js is not a huge fan of CommonJS. And Node.js is not a huge fan because like there was a lot of things that didn't in the CommonJS standard which did not like align completely with Node.js itself, and people like these few things would probably not work out, and people decided let's just not follow this standard to the last letter. Maybe just follow it until we can, and then just improvise. And there were front-end implementations for this, Browserify and Webpack. But CommonJS also hates front-end JavaScript because the synchronous requires, and people like, why would we do this? Why is this a good idea on the front end? It's not. So people had an idea. Let's make a proposal that would change fundamentally how CommonJS dealt with these things. And the proposal is popularly known as module/transfer/C, and it's like it makes no sense until AMD. So that proposal was nothing but like the AMD standard, but like this was such a huge rethinking of the whole CommonJS specification of the whole CommonJS line of thought that people like, yeah, let's just fork the standard, let's just make a new thing, and boom, we have AMD. So October 2010, AngularJS came around, and if you remember AngularJS 1.x, it had a similar, not a module system, like a similar component system. We're like, okay, define this, and then use that in a function. So Dojo started using AMD as well in October 2010, and it was great, but like not up to the mark. So James Burke, who was dissatisfied with how Dojo worked, started Require.js. And Require.js is something that people, at this point, people are like, yeah, something's happening in the whole AMD. And AMD started getting popular. Now, all problems are solved. Let's go home. Not quite. So the problems before AMD and CJS were there were no dependency resolution, and there was namespace pollution. and we've dealt with those, right? But there are problems after AMD. So the first problem that I believe existed in AMD was verbosity. It was not like compact enough. The syntax was a bit much for people. There was a certain amount of strictness pertaining to orders, so like, and now you're like, this guy's just lazy. Just follow the exact order, it works. But in certain huge applications, people reported that as an issue they faced, like just reordering everything was sometimes a huge problem. And the biggest problem is just HTTP 1.1 things. It made absolutely no sense in 2010 to like ask for 10 or 20 files from JavaScript files from a single server. It's like, why do we go back and forth so much? It takes a lot of time. So JS developers decided to just use CJS on the browser. They were like, I'm going to pretend I didn't see that. And I was like, OK, here goes all that work. But in order to fill that gap, in order to enable people to write common JS on the front end and also like deal with this new issue of, OK, how do we, a new issue in the sense that people just realized that we can like go back and forth all the time with the server. People created module bundlers. So there were module bundlers like Browserify and eventually Webpack that would allow you to write CJS code and then run that bundler and get a single bundle file. That's amazing. We get one huge JavaScript file, and it's terrible, but at least it loads fast. So now everyone uses CJS on the server and browser. Congratulations. Order has been restored to the galaxy. Again, we can go home, right? But module authors were kind of dissatisfied at this point. So how do I enable people to use my module without worrying about which format they care about, right? If you're trying to use different kinds of formats and modules that have like 7 kinds of module formats, like how do you deal with all of them? So in late 2011, UMD was created. Nobody liked it, pretty much. But UMD was like the OG of interop. It was like, OK, let's bind all these together. And it was formulated by Adi Osmani with the help of James Burke and the others. And the story, in my opinion, about UMD was pretty much this. It's like, OK, let's create one standard that fixes all standards, but you create a new standard. So at this point, everybody was really, really fed up. But like, if there's one person, like one group of people who were fed up more and more, was
that is enough.
And TC39 was like, OK, we're done with all this nonsense that's happening. We need to, like, let's address this. Let's add modules to the language. And that was cool. So in July 2014, we get, like, in the meeting in July 2014, we kind of, the TC39 committee that was responsible for adding features like ES modules decided, OK, we're going to do this. And how are we going to do this? So awesome. ES modules now give us static imports. And static imports are awesome because they can find all sorts of faults in your code that Node.js couldn't with CJS. And the best thing is you can get that at load time, which means you do not have to deal with them at compile time, which is nice. But obviously, it crossed a lot of swords with CJS. And by extension, it had to cross swords with Node.js because like Node.js is so much in on CJS at this point. It's like, no, we literally cannot alienate an entire user base. We have, like, static imports is not something that fits the current model. And the way static imports and asynchronous loading worked, among other things, in ESM, Node.js was like, this forces us to rethink the entire format. This forces us to like start from the scratch board again, because this does not fit inside our current order at all. So support for dynamic imports have been added, which kind of paved the way for more and more interop to the point where like they can soon be compatible enough that you won't care, and you could use ESM modules inside CJS module, which is required by an ESM module, and your own file is CJS. But yeah, it's getting there. It's not there yet. So we'll talk about that, but yay, static imports. So as a language feature, we finally get static imports. The benefits are like you get static analysis, obviously, but tree shaking. You get to know what needs to be loaded and what not, and just tree shake the hell out of your modules, and yeah, get smaller bundles, better parsing times, whatever. And there's also the dynamic variant, which helps people do stuff if they don't want any of these things, which is a use case, right? If you want to conditionally import something, you should be able to do it. So everything was perfect, right? Not quite. So one of the biggest issues that ESM, in my opinion, had was ecosystem distribution. Basically, the entire JavaScript ecosystem at this point was using CommonJS, and everybody was getting comfortable to it, but they were like, okay, go away. But enough talk. Let's now get to the nice part. Let's see how it all works behind the scenes, because too much history. Fun fact before that. A lot of people do not know this and assume the worst, but the module systems in Node.js are mostly written in JavaScript. Like, I know a couple of subsystems that are 100% C++ or something, but module systems almost completely written in JavaScript. You could appreciate them, understand them, read through them, even if you don't want to do any native C++ stuff. It's perfectly fine. It's awesome. So let's start off with a few VM fundamentals, because by show of hands, how many people have dealt with virtual machines before, with VMs and compilers and parsers stuff? Nice. Not a lot. For the other people, I got you. So firstly, isolate. What's an isolate? An isolate is a VM instance with its own heap. So basically, when you're making a VM, it needs to have a heap for allocation and garbage cleaning, whatever. And V8 is like, OK, so you have a heap, and you two, you share a heap. And yeah, we could talk about how this works out, but not the important point. The important point is, what is the job of the isolate? Like, we know it exists, but yeah, it basically does heap allocation and garbage collection and just defers almost everything else to internal structures. So as an aside, how does it all work? So basically, you have the isolate, which has its own heap, one single heap, and you have the C++ stack, assuming you're dealing with V8 or something like that. And then you have GSLAN, which is where fairies live. So you have objects inside the heap, and you need to access them from the JS. Like, what's the point of creating a new object inside the heap if I can't get it, right? So you can get a pointer to that object, but this comes with a lot of problems. Now, one of the benefits of the pointer is that it just works often. Like, you don't have to update it, whatever. But pointers are terrible for this thing, because you'd never know what to garbage collect, for example. So it can open you up to memory leaks, because stuff is just sitting around forever. How do you know if it needs to be cleaned? Like, C++ has an explicit structure where you could just free stuff in the memory. JavaScript didn't want to have that. JavaScript wanted to be easy and convenient. So we didn't need pointers. Also, because of how garbage collection, like modern garbage collection works, objects usually do not stay in the same place forever. Objects move around a lot. They are moved around a lot. Imagine it like defragging a old Windows computer. In order to optimize for the coming stuff, you need to like defragment all your existing objects, and that is why they move around a lot. So instead, you have a handle. The handle actually gives you access to the object which could be updated. And then these handles, so you could, on side of V8 or like whichever VM you are in, you could just take a look at all the handles that exist for any given object and just see, OK, all the handles for this object no longer exist. So let's just destroy this. And you could have multiple handles which after a point becomes a mess to handle, pun intended. So you, okay, sorry. Wow. But yeah, in order to handle the handles, you need a handle scope, which is basically just a bunch of handles together. And you can just forget about individual handles because there's literally hundreds of them all the time, and you can just deal with the scope, and the scope moves together. And it's called a scope because that's how we visualize handles to be grouped. What do we call a group of handles? A scope, because that's the most logical grouping of handles. That's the most common use case of deleting a bunch of handles together because they went out of scope, right? Cool. So next up is context. What is a context? So a context in V8 lingo at least is a sandbox execution context with its own set of built-ins and functions. So a context basically is an execution environment, right? It allows separate, unrelated JavaScript code to run inside a single instance of V8. And you must explicitly specify the context in which you want any JavaScript code to be run. So you have an isolate and multiple contexts inside the isolate. Now, your JavaScript code can run in this context or this context, doesn't matter, but it has to run inside a single context. You could make different contexts for everything that you make, or maybe run all your code into a single context. That always works out, but they basically are just an equivalent of global objects and a set of JS built-ins. So that's cool. So basically, we have the Node.js process, which is like a huge thing, inside of which are threads. So yay, we have worker threads. You have multiple threads in Node.js. Each thread is a worker. You have a libuv instance and a V8 instance inside each worker, which is basically the event loop and the isolate. And the isolate is nothing but heap and GC stuff. And you have a Node.js environment inside all of these. And it's just this bunch of built-ins. It's just a bunch of core APIs that exist for Node.js. It's a reference to the module system. It's a reference to the file system and everything. And these Node stdlibs, in turn, contain contexts, which your code could run in. So basically, inside, this is your entire Node application, and any of those contexts could run your code. And this offers to be a basic map of how things work. But then, OK, how do loaders work? It's all cool to know about Node.js, but how do these loader workflows even work? So loaders have three main steps, three main jobs that they do. The first one being fetch. So the loaders have to fetch your code and get it. And it sounds simple, but it's mostly not. Then they have to do some transformations on your code to make it better. And then there's an evaluation hook that runs your code and returns what you really need. So if you think really simply, it's just resolve and then see it. So basically, once you resolve a module, you have to check if it's cached, because if you're not caching modules, it'll take a lot of time. Imagine what would happen if every time you required Express or Webpack, it would do it all over again. That's huge, right? So if it's cached, good, return it. But if it's not cached, you need to instantiate a new module and just add it to the cache. Simple, right? It's actually not that simple, but this is mostly the basic idea of how the flow works. Any flowchart bigger than that, and it would be really messy. So the common JS loader, what is special about it, and how does it follow this stuff? So CommonJS has synchronous loading and inline execution. And that sounds like a messy bunch of jargon pulled together, but that's actually really important, because this highlights the most fundamental difference between ESM and CJS. It loads stuff synchronously and executes it in line with the rest of the code. So how does this all happen? Let's cut all the stuff and get to the important things. So you call require, which actually requires just a wrapper around module.prototype.require. So it's essentially this function which is running all your require stuff. And module.prototype.require actually calls module.load, which is, again, a weird function. But what does it do? How does it fit that flowchart? So first, it finds the file name of the module that you want it to look at. That's resolve file name. and then it checks the cache. So it looks for the cache and sees if like the module already exists. If it exists, then just return the cache. Otherwise, check for a bunch of native module stuff. It's really weird and too technical, but like we could talk about this later. And if it's not a native module and it's not cached, then make a new module instance. And it feeds all the file name and all the extra data to this module constructor and store it in the cache optimistically, and then checks. So it optimistically stored it in the cache just to be like, OK, let's just assume that it'll work out. But then it actually has to see if it works. So in module.load, it basically literally tries to run that function, and if it throws, it said it threw, right? So so this try catch block is basically trying to run the actual module compilation, and if it threw, well, just delete it from the cache because it's not a good module to keep. Otherwise, just return the module exports object if it's perfectly fine. So module.load was something that we called in that one. And so let me tell you, it's like the workings of module load are really complicated and takes a bit of time to really appreciate it, but it finds the appropriate extension for the file and takes appropriate action. And the rest assured for JS files is pretty simple. It just reads the file from the file system, literally, and then just compiles it. But then what does module.compile do? It's so complicated. So nothing. Module compile does nothing. It's really simple. It just takes your code, wraps it around a bunch of strings, and just compiles it. It's all good, right? I mean, we're all writing great code, and strings are nice, so let's do it. Although it's not. It's not that good because this opens up a lot of security issues. And this is, from most perspectives, it's not a good thing to do because like this doesn't give you performance. This doesn't give you accurate coverage. It's mostly a bug. And so when I saw this, I was like, OK, this is code that works, but this is duct tape code. And we don't want duct tape code inside a runtime that we want to be the best in the world. So we use something like v8 compile function, and it's a completely different thing. It's much more convenient. It's much more simpler. It's cleaner. But yay. So that is something that is fixed now. But yeah, the ES modules loader, like how's it different? What's happening here? So ES modules have asynchronous loading and synchronous execution. Basically, what this means is that, and as we discussed, it makes a lot of sense in that if you synchronously load stuff from the network, which is something that ESM was designed to do, to exist in the front end, it doesn't make an awful lot of sense. It does not make an awful lot of sense because that network hit that you're making, it's very expensive. Compared to the file system hits that Node.js makes, I mean, file systems are slow as well, but not as much. You could inexpensively pick stuff up from the file system, and that would just work out. But the same does not apply for something like the network. And that is why we hit a couple of problems with the whole thing. And they were like, yeah, CommonJS in itself could never really work out for the browser and ES modules. But the problem in this is this is so fundamentally different with how Node.js sees these things and works with these things. It just doesn't fit the execution model. And it doesn't even make an awful lot of sense to like have exactly this kind of stuff, like to have the exact same flow for Node.js and for browser.js. Also, so because of a lot of these problems, Node.js was not only reluctant to implement ES modules at first, it went to the point where it's like physically impossible, like literally impossible for them to reasonably do any of that stuff because, like, how can you? So the thing about that is a lot of that stuff is changing now. A lot of that stuff is changing in the sense that there's more and more functionality that is being added. There's more and more variations that are being added in the spec as we speak to account for the use cases that Node.js relies on, that CJS relies on. Then that is opening the roads to interoperability, but yeah, it's slowly working out, and we're getting there. But how does this work? So you see asynchronous loading, but like how asynchronous is asynchronous? Like how asynchronous is the import function? It's async enough to have the async keyword in its definition. It literally just gets the module job and awaits. So the loading is asynchronous because it's an asynchronous function, but because inside the async function, it's awaiting the actual compilation, the execution itself is synchronous in Node.js. So it synchronously waits for the module to get compiled or get fetched from the cache, whatever, and then just waits for the job to run, which is like to execute the module and find out what it returns, and then return this namespace of this module. And guess what? Loader.getModuleJob is pretty much exactly in line with CJS, right? I mean, the core flow that we talked about in the flowchart, that is pretty much consistent everywhere. So even if ESM fundamentally is different with how a lot of these steps are like sequenced and parallelly executed or whatever, it does follow like the same kind of flow. It looks for the cache. It tries to load stuff up. So first things first, it resolves, obviously, the package. So you have the specifier, and you have the URL of the parent, which it then uses to resolve the whole module. For bare imports, it's just one, the name of your module that you need, and this resolve function would then return the URL and the format of the module that you're looking at. Now, the URL is important, right? I mean, you found it in the node modules directory. You found it in the immediately closed directories. You found it somewhere. It needs the URL to actually read it and do stuff. But the format is important now. The format is important because you can import CJS files inside ESM, and you can import ESM files inside CJS. So you need to handle these formats differently and think about them all the time when you're writing this code. Awesome. So this does resolve, just resolves this, simple. And then it does the exact same caching step. So it goes to the module map and tries to find the appropriate module for the URL. If you find the URL, then it's great, problem solved. But if the job does not exist, well, we need to go further and actually run this stuff. So yeah, job equals new module job. So what this does is it actually starts a new module job, and the new module job is like started with the instance of the loader that you want, and like it feeds the URL, which it uses to get the module from the file system. You set the module in the module map so that next time you hit the cache, you get the module, and you return the job. Simple, right? So what's inside module.job? A lot of weird stuff, and that's the cream of the whole interoperability area, right? That's where we kind of try to make things work, and it's complicated. And I'm like, okay, let's talk about it later, maybe in the discussion room or something. But it's complicated, and one of the things, and interesting things, was because of a lot of this interoperability stuff, because of stuff like dynamic imports and cyclic imports and stuff like that, people would come up to me and they would be like, hey, I need to ask you a question. It's like, what? Does ESM use CJS internally? Is import just a wrapper around require? I'm like, no, it's actually the other way around. So like require is a wrapper around the dynamic import function, because like ESM is state of the art, and why maintain CJS and then maintain ESM on top of that? So why not reverse it so that you could just have CJS as a layer on top of ESM and then like potentially make changes to it in that way? So yeah, module job is complicated and not in the scope of this presentation, but we could talk about it later. So basically, interop in a nutshell, basically pertaining what this file and everything does is it takes care of dynamic imports, because like every import in Node.js, CJS format we've been doing, they're all dynamic. You never know at load time what a module is going to return. And that is a problem because because CJS modules dynamically import and export stuff. There's no way that you could use that format to statically export things. And the problem with that is because ES modules always used to statically import and export stuff, there was no pathway inside ESM to actually handle this case. There was no pathway inside ESM to actually think about how to take care of this case. And that is why people decided to do something about it. So there's now a proposal on for expanding ES modules with dynamic imports. And a lot of people have already started implementing it. It's not inside the spec yet, but it should be. And it's by Dominic. And what this does is it opens up the road to interoperability in a very fundamental way, in the sense that it adds a whole new ability to ES modules, which is to handle stuff that is exported dynamically, which is not statically exported, which means, in turn, that you could essentially consider CJS files, CJS modules, to be a special case of a dynamically exported ESM file, and then handle it like that. So about that, there's a lot of cases, there's a lot of edge cases. There's cases where people like to import ESM inside CJS, inside ESM. And a lot of these sandwich cases are still very breaky and flaky and whatever. But it's improving. And usually the problem is when you go from dynamic to static to back to dynamic. But it's slowly coming into picture what the next way forward is. The second thing that people love to talk about is cyclic imports. So basically, you could have cyclic imports in the sense that you could have a module that requires other modules, and then that requires the first module. And the cycle goes on forever. There's not a lot of ways to handle these things in like a couple of these specifications. And funnily, the way it is dealt with is very different in both the formats, and that is one of the things that drives people crazy, because that's something that you cannot interoperate between like clearly, because CJS allows you to have cyclic modules. We have it all the time. Like Webpack requires some other module, and then that requires Webpack. It happens all the time. But like ESM was never built for this use case, and it gives the idea that ESM never took runtimes like Node.js, runtimes like Deno as one of its targets. It never considered that these cases would be very real, because they're not very real on browsers. And it's not technical at all, but like what my opinion on this is that this demarcates a very clear shift. This is a great time to be in this space of backend runtimes, because now the TC39 is opening itself up to considering these things. Now there's people from Node.js actually sitting on the boards of these committees being like, you know what? You don't just build for browser vendors. There's not only browser vendors on this board. There's not only V8 and SpiderMonkey people. There are people who represent Node.js on this board who would go up to them and be like, okay, this does not work for us, and let's rethink this. So there's a couple more, but these are basically the two biggest hurdles. And dynamic imports was something that I was clear that it's being worked on. But guess what? Just yesterday, actually, so you see it's super duper new and it's secret. But Alex Roshma actually shared a gist file. And this gist file actually, considers and rethinks how ESM's transparent support for cyclic imports work. Now, because this was just literally yesterday, I did not have the time, and I was also too lazy to actually go through it in its full entirety and then make enough slides for you to think about and me to talk about this stuff. But this is amazing stuff. You could look it up and read it and realize how they're moving forwards with stuff like this, because it's really important for 100% transparent interop to happen. So that is the second biggest problem gone right before the conference. I'm like, okay, do I even need to get this talk at this point? But yeah, it's taken care of. And this basically, with this, I tried to look at some of the issues that we have in this space. And just to give everybody a good idea about the problems that we have, it's like people go to Twitter and it's like, oh, Node.js is written by retarded people because guess what? You can't do this simple thing. And it's like, guess what? There's problems. And so this was basically a basic idea about what the hurdles are and the problems are. And also, we looked through some of the code, which is not super duper good. But the core idea is that the source code is sometimes the final source of truth, in the sense that it sometimes differs. Like, it literally differs in the case of CJS from the specification and the actual standard. But like also in the case of ESM, it's physically not possible for us to like ship it directly without thinking about it right now. So the code is so fundamentally different than the specification sometimes that a lot of the arguments that are theoretically true do not make a lot of sense in the practical, like practically looking at these actual constraints in the code. So that was my idea behind giving this talk, and I hope it reached that goals. So before I end, I want to give special thanks to a couple of people who helped out with this, with the code and the implementations and everything, and also these slides. There's Miles Borins from the TSC in Node.js. There's Anna, also from the TSC. Thanks for all that stuff. There's Shelly from Electron and Node.js. And there's Dimitri from HolyJS, who gave this awesome idea and really pulled with me on this. And also the organizers. You're amazing. So, Super Bowl show.
Thank you very much for your talk, and it's time for the questions.
Yeah.
We have special chairs for the questions.
Oh, wow.
Yeah, you can choose any.
Okay.
So, right now we have two model systems. It's not really convenient and other things. What do you think? Maybe in distant future, or maybe one day we will have one model system. What do you think? What it should looks like?
So that's an amazing question. Thanks for that. And a lot of people are really skeptical of this. It's like, okay, so where are we heading to? Would you have like 17 model systems in more years to come? I'm like, probably not, because as I tried to outline, the problem, the whole issue with CJS was that it did not make a lot of sense on the browsers. And I mean, fair enough. So you start ES modules. And then the problem with the ES modules is it does not make a lot of sense on servers. So we're trying to fix that. So hopefully, and Deno is doing amazing work in this field. It's like it really bought into the whole idea of let's just use ESM and like make sure that we can just use what people use in browsers to end up still giving a comfortable experience to our developers. Sadly, Node.js has to move much conservatively, especially because CommonJS, a lot of people very, very heavily rely on CommonJS. I mean, we all technically rely very heavily, but like you can't just break everything. You can't just throw it out of the water. So I don't know how long CommonJS will be around. Probably always, maybe. But the way it looks to me right now is that slowly and steadily, ES modules will, replace CommonJS in most areas, and eventually, like there will always be people who would write CommonJS, like who would have not changed their code and still want like Node.js 20 to run it. But most new projects would work with ESM. It's like I realized that ESM is technically like what's meant to be. Is the prodigal son. It's the model system of JavaScript because it's like official and standardized and it's amazing. But it's being iterated upon. It's we again live in this amazing time where it's like we can see this coming home. We can see this working out slowly and steadily, and hopefully in a few more iterations, ES modules will be perfect for every use case. So that's close to the one module goal. I do not believe Node.js would remove CJS anytime soon, but
so if one day you join TC39, so which feature will you add to model system? What you missed most?
Which feature will I add to the module system?
Yeah.
That's an interesting question. Thanks. I really need a lot of time to think about it, I think. But like, one of the problems I believe with module systems is that it's sometimes really uncertain of how certain things would work out, and like it's moving to ES module is moving towards that goal, which is making things transparent and exposing all these hooks and stuff. And maybe I'd want to improve them in that space. Yeah.
Okay, thank you for your talk. You can find Ujjwal in the speaker discussion zone, and thank you.
I'll see you there.